Today's question is about resistor networks. The figure below represents a circuit diagram of 3 resistors connected to a 12 volts battery. So we have the diagram here. Determine the effective resistance for the arrangement above, that is for part 1, and part 2, the potential difference across the 3 ohm resistor. So let's begin with the first part, the effective resistance for the arrangement. Now we're going to have this. For this section here, we are going to combine the resistors. We have resistor 5 ohms connected to 4 ohms and 3 ohms. So 4 ohms and 3 ohms are in series, and therefore we combine them by adding them. So this gives us 7 ohms. And then finally, these 2 resistors can be combined. So we are going to have it as follows. So the effective resistance is equal to, so the 2 resistors here are in parallel. So we'll have the product of resistance 1 and resistance 2 over resistance 1 plus resistance 2. So that should be resistor 1 in this diagram is 5 ohms and resistor 2 is 7 ohms. So we are going to have 5 times 7 over 5 plus 7. And this is 35 all over 12. 35 over 12 is 2.9167 ohms. The next thing is to determine the potential difference across the 3 ohm resistor. Let's get back to the diagram. We take note that when these 2 are combined, then this resistor, which is now 7 ohms, is parallel to the 5 ohm resistor. And for parallel resistors, they share the same voltage. So the total voltage here is the voltage across 5 ohm resistor and the 7 ohm resistor. So here we have 12 volts. Oh, sorry, it's voltage, not ohms. And here we also have 12 volts. So we are going to get the current across 5 ohm resistor, and from that we'll also determine the current across these 2 resistors. Remember, the 2 resistors share the same current. So let's get total current first. Total current is given as the total voltage over total resistance. And the total voltage is 12 volts. And total resistance we've worked out here, 2.9167. So from this, the total current is 4.1143 amps. And just as we had seen, the voltage across 5 ohm resistor is 12 volts. Voltage across 5 ohm resistor is equal to 12 volts. And therefore, current through the 5 ohm resistor is calculated as the voltage 12 volts over the resistance 5 ohms. And this should give us 2.4 amps. Now this should help us determine the current through the 3 ohm resistor and 4 ohm resistor. So the total current, as we've determined, is 4.1143. Now this current, when it comes to this junction, by Kirchhoff's law, it splits so that we'll have some current flowing to the 5 ohm resistor and the rest through the 4 ohm resistor and 3 ohm resistor. So the current through 5 ohm resistor we've gotten to be 2.4 amps. That means the remaining current will be flowing through the 4 ohm resistor and 3 ohm resistor. So the current through the 3 ohm resistor and the 4 ohm resistor is given as the total current 4.1143 minus the current through 5 ohm resistor, which is 2.4 amperes. This is 1.7143 amperes. Now with this, we can therefore determine the potential difference across the 3 ohm resistor. Now remember, that is what you're asked, the potential difference across the 3 ohm resistor. Now the potential difference across the 3 ohm resistor is equal to current through 3 ohm resistor times the resistance. Now remember, current through the 3 ohm resistor is the same current through 4 ohm resistor, and that is 1.7143. So we are going to have current through the 3 ohm resistor, which is 1.7143 times the resistance, which is 3 ohms. And that should be 5.1429 volts. So that is the potential difference across the 3 ohm resistor. Now with that, we mark the end of the solution to this problem. Thank you for watching. See you next time.